everyone, David Gillo here with Ozen Engineering, and in this video I show how to apply Ampere's law to a BH curve using two operating points, one in the linear region and one in the saturation region, to see how the flux density is in the magnetic core material based on the operating points. Okay, so if we look at the material, AK steel H0, we can see the BH curve here, and we can which I exported this data to this Excel sheet, and we see that if we apply excitation current corresponding to H equal to this value 10.0233 amps per meter, right? And if we integrate around the Amperian contour, we determine how much current we need to apply to obtain a maximum B value of 0.818015, and this is in the linear region. Okay, and then if we look at our model, I have set up a magnetic core. If we look at it in this view, right, the inner radius or the inner diameter is where maximum B and maximum H will occur, because based on Ampere's law, if we look at this equation here, the line integral of H around the Amperian contour equals the total current enclosed. And in this simple example, I'll just have one conductor, straight long conductor, going through the center of the cylindrical core, right? So I apply this excitation for the winding, right? So the total current enclosed is line integral H times the total distance around the Amperian contour, which is a circumference, 2 pi times r c, which is radius of the contour, which is this inner radius of the magnetic core. Okay, and that gives the total current enclosed, and this is magnetic transient solver. So this current excitation and flux density will be sinusoidal. So after applying this excitation, which I define here, I'll show you, H linear, right, linear region, H in the linear region, which I showed you, 10.0233, I'll show you again, corresponds to a B value of 0.818015, and then in the model I got 0.801, which I believe is less than 3% difference. So it makes sense. This is what we expect. Now similarly, if I do same thing, but now I pick a operating point in the saturation region, right? I choose here operating point saturation region, H equal to 101,500 amps per meter. I apply Ampere's law to determine the total current enclosed, and then we expect to get a maximum B value close to 2.0891. And then after applying that, here we have the results. The result maximum B is 2.035 Tesla, and this is what we expect. Again, less than 3% difference. And we see how Ampere's law, the expression for H over here, we see how H or B will be inversely proportional to R, to the radial distance from the conductor. And we see that indeed that the B value decreases moving away from the conductor, right? The magnetic field lines get weaker and weaker as we move away to the outer radius of the core. So there I showed how Ampere's law is applied to operating points on the BH curve. I picked a point on the saturation region, one in the linear region, and show that we do obtain the expected maximum B values. Okay, that is all for this video. Contact us to learn about our simulation capability and request a demonstration for us to show you how we can help you with your engineering projects. We provide training to use Ansys tools and offer consulting services. If you like this video, give it a like and subscribe to our YouTube channel to be updated and notified of new upcoming videos. Thank you very much and have a nice day.